Imagine a noise so strong it rippled across 5,000 kilometers of open ocean, picked up by hydrophones built to track quakes and distant rumbles. And yet, it wasn't a tectonic earthquake. Later evidence would tie it to ice quakes instead. At the time, it was an unknown, a pulse unlike anything ever recorded. NOAA researchers noted it was far louder than any known animal call. That single fact ignited wonder. Could something alive really be behind it? If you enjoy vivid mysteries and deep visuals, like and subscribe. It helps us bring these stories to life. The answer, as we'll see, unsettled both scientists and listeners. Because the noise rose like a living voice, yet no species could explain it. That question, the sound that should not exist, is where our story turns next. In 1997, the monitoring network suddenly picked up something researchers could not classify. A vast, low pulse rose slowly through the deep, caught by NOAA's Pacific Marine Environmental Laboratory hydrophones. These instruments were tuned to track earthquakes, the thunder of shifting ice, and the voices of great whales as they traveled ocean basins. Most of what they recorded fit into neat categories, but this new arrival did not. It began faint, building in pitch like a living call. Over roughly 1 minute, the sound rose in frequency, tapering into a shape that looked eerily organic on spectrograms. To scientists reviewing the scroll of data, the curve had the profile of biology. Yet NOAA scientists noted one crucial detail. It was far louder than any recorded animal vocalization known at the time. Blue whales, the loudest creatures ever measured, can send their voices across hundreds of miles. But nothing cataloged came close to this amplitude. Submarine systems, though powerful, leave structured and mechanical marks. This was different, fluid, almost natural, and yet immense in scale. What made it even harder to dismiss was how far the sound carried. Hydrophones thousands of kilometers apart registered the same event at nearly the same moment. That meant the signal was strong enough to ripple through an ocean basin, louder by orders of magnitude than ordinary biological calls. To the public, the scale suggested something almost mythical, an unknown giant declaring itself in the abyss. The possibility gripped imaginations and spread fast. Speculation branched in many directions. Some wondered about hidden military machinery, vast engines in the South Pacific. Others preferred visions of undiscovered leviathans, creatures larger than any whale. The resemblance on spectrograms encouraged the idea, a voice that looked alive but came from nowhere known. Stories spilled into newspapers, late-night talk, even playful cultural references. The bloop became both a scientific puzzle and a public obsession. Understanding why it was so puzzling requires a pause on sheer volume. A blue whale's call, up close, already teeters at the edge of our hearing tolerance. Multiply that strength several times, and you enter the gulf between known biology and what the hydrophones had captured. For biologists used to scaling sound with body size, the implication was staggering. A creature large enough to create a call of that magnitude seemed almost beyond possibility. So why then did the signature echo patterns familiar to life? For years, scientists tested that question against data. Each sample was compared to cataloged whales, deep-diving fish, even rare squid recordings. None lined up. Machine records failed too regular, too metallic. The trace persisted, stubbornly organic in outline, but unmatched by any living source. It hovered outside categories and lingered on charts as unexplained. That endurance only amplified its hold. In scientific circles, the bloop was shown as an outlier, a reminder the ocean still whispered in unsolved codes. In the wider world, it kept the door open to legends and speculation. It was not proof of monsters, but it was proof of the unknown. And that, in the imagination of both scientists and the public, was powerful enough. Still, the absence of a biological match forced a turn toward other explanations. If not whales or machines, then perhaps something far older shaped the sound. A force less alive, but no less dramatic. So what could make the sea echo in the rhythm of a living voice? The story eventually shifted south, toward the icebound edges of Antarctica. What researchers learned there reframed the mystery entirely. The bloop, once imagined as a call from something alive, turned out to echo the roar of breaking ice. Beneath polar cliffs, enormous glaciers strain under their own weight. When stress builds beyond their limits, they fracture with sudden power, events known as ice quakes. These are not faint cracks. They are violent ruptures that send sound pulsing across the ocean floor. Hydrophones meant to hear tectonic movements suddenly register the thunder of splintering ice. At first, scientists doubted this connection. Ice quakes were acknowledged phenomena, but their reach was assumed to be short. The bloop had been recorded thousands of kilometers away. That scale seemed impossible. For years, the idea of an iceberg mimicking a biological voice felt less likely than the fantasy of an undiscovered animal. Yet new evidence overturned that skepticism. Between about 2005 and 2010, NOAA's Pacific Marine Environmental Laboratory deployed hydrophones closer to Antarctica. Those instruments captured fresh ice quakes in the Southern Ocean. Their spectrograms rose and faded in exactly the same pattern as the bloop. The similarity was too precise to ignore. One case in particular gave the theory weight. In early 2008, a giant iceberg known as A53A disintegrated near South Georgia Island. Hydrophones recorded its collapse, and the resulting signal matched the bloop's distinctive rise almost note for note. With that recording, the puzzle sharpened. The source was not a colossal throat, but disintegrating ice. The way ice makes such a sound can be grasped through simple imagery. Inside a glacier, ancient air is sealed in pockets. When pressed and released, those pockets behave like bubbles bursting in boiling water. Tiny collapses magnified to continental scale. Add the grinding of bergs pushing against one another, and the releases surge outward as low-frequency waves. Seawater conducts those signals with extraordinary efficiency, carrying them across ocean basins. To put this in perspective, calving icebergs are like mountains sliding in slow motion into the sea. A single collapse unleashes energy vast enough to rival any animal call ever recorded. On a spectrogram, the shape mirrors what once seemed alive. But the voice is geological, not biological. Scientists now recognize these eruptions as part of Earth's soundscape. And they are not rare. As global temperatures rise, glaciers thin and fracture with growing frequency. Researchers point out that these ice quakes are becoming more common, reshaping what the ocean sounds like. What was once an occasional signal is turning into a chorus of shifting ice. Field surveys in the Bransfield Strait and Drake Passage confirmed the link firsthand. Teams recorded ice cliffs shattering and bergs grinding apart, then compared the traces to the archived mystery signal. The curve was almost identical. In one moment, the bloop was explained, an echo of Earth's frozen edges tearing loose. The search for monsters gave way to a clearer truth. The bloop was never alive. It was the sound of ice breaking, magnified by water until it roared like a beast. The monster vanished. What remained was ice, not flesh. The bloop was not evidence of a hidden sea monster. Research points to ice quakes as the source. NOAA's PMEL acoustic program later confirmed this by matching Antarctic icequake recordings to the original signal. What once appeared like the trace of a living call was revealed instead as Earth itself releasing pressure in ways few expected. That clarity strengthens the real takeaway. The unsettling part is that these powerful ice events are becoming more frequent as polar ice changes, reshaping the ocean's soundscape. Subscribe and turn on notifications to keep exploring mysteries like this with us.